viewers. Hope you guys are well. See if you can get yourself in shot there, mate.
Hey guys, good to see you all again.
Yeah, for those who haven't taken part in these events in the E-Series before, we're the two Joes with directors here at Go Naviro, specialising exclusively in Golang resource solutions, doing a lot in the community space, live and online, and it's great to see guys here from all corners of the earth. So fantastic talk today on production ready concurrency in Go. So really looking forward to that, guys. Everybody get on Slido as normal. As Katie said, there will be some code to look at today. And yeah, plenty of giveaways from the tech quiz, also the Go for card game, and the most upvoted questions. So, you know, the more questions that go forward, please do like what you want answered, and we'll get through the top 3 in event today. So yeah, Joe, number 2 over here, will take us through the order of play today.
Yeah, hey guys, yeah, really happy to have you all here again. Another record-breaking event, hundreds of you registered, so really good to see, really pleased with it. As usual, I think you all know the drill by now, but for those who don't, we have our brief introduction, we can't have without. We then roll into the Go for card game as a little icebreaker just to get people familiar with Slido. And if you're not already, you need to just be scanning that code that's behind Joe there, that's available in the chat as well. Just scan it, make sure you're in so that you can ask some questions, take part in the poll, and of course take part in the Slido games. After the quick Go for Con game, we'll be rolling into Egon's chat on production ready concurrency for about an hour or so. And then of course, rolling into some question and answers. There's going to be the prize giveaways. You know, you've got the Go for card game. So cards are on offer again when it appears. The disappearing actor,
disappearing cards,
the Houdini game we've got, and then of course some prizes for best question and answers. So I think, what's the time? We've got a little bit more. We'll just let some more people sign in because the numbers are rolling up. Can you share the Slido code?
Yeah.
So the Slido code on the chat box is GoCon. If you guys can see it, that's the one you want to put.
Hashtag GoCon. The link should be in there, but just copy that again, Joe, so everyone can see it.
There you go. So if you just want to follow that link there, copy and paste it. That'll take you right through to the Slido app where you can register and get involved in the interactive games.
Yep. So obviously we're all here for the tech talk. That's going to be the core of this presentation, but it's going to be super fun too with the tech quizzes, looking at some code. So I'm sure you guys will enjoy that. Just to kick things off, this little icebreaker, Go for card game, cards up for grabs. We dished out these last night on the dining room table. As always, they are completely random the way they come out, so don't hold it against us if there are any surprises in there, but we will see. The card comes up and then it's higher, lower, or the same. You'll see the answer when the next card comes up from there. So it's just going to be 5 quick higher or lower or the sames on that. And then we'll get straight into the talk, Q&A, and wrap things up.
Yeah, there's been some big giveaways the last few weeks. We've been sending out a lot of merch. Some of it's in the post to last week's winners, cards, and Go for merchandise. So you guys will be receiving it soon. And yeah, look, you can see the numbers rolling up. We've got about 12 people into Slido so far. Want to keep you guys should have joined the quiz. Can you see it? Oh yeah, I think it's all there. So we've got about 45, 46, a few more registered. We'll just give it a little bit more time to get in. Don't forget, yeah, flying up, good numbers. It's the only way you're going to win these cards and take part in.
Got to be in it to win it, as they say. Ryan Reed, Ivan Francis, welcome. We got Parsa, Mohit, Rupert Pumpkin.
Lovely, yeah. Got some return names, I see, some new names as well. It's rolling up. We've got some good numbers here, guys. Loving it.
But, yeah, anyone who watches Entourage may get the Rupert Pumpkin reference. But yeah, look, guys, wishing you all the best of luck in the games and hope you get a lot of value out of these talks. We'll be putting together post-event videos for all of these events. So don't worry if you missed the first couple as well. We'll get that over to you guys so you can use that as a library of content whenever you like. So we're pretty much ready to crack on into the game.
We'll start the game.
Yeah, cool.
Yeah, right. We're good to go, guys. Higher or lower on a 9. Nice and easy to kick start. I'm also taking part, and I don't.
Higher, lower, or the same. Remember,
results.
53% went lower, and that was correct.
Yeah, we've got half the field going forward. Lovely.
Okay, number 2. So again, we're on 4 this time. Higher or lower, or the same.
I think that's a curveball.
These are completely random. They were dealt and shuffled last night.
Oh, lower.
Lower again. Congratulations, the 11%ers. It was a 3. Little go for cooking up a steak. Higher, lower, all the same.
This game's
76 went higher.
Yeah,
which was
you
correct.
Gotta be right. I like the
congrats. So guys, attended some events before. I think a previous prize winner as well.
Double,
so
yeah, no, joint leaders though. Push one. Look at that.
it's
double,
fastest
double.
finger as well. So get your answers in as quick as you can. Higher, lower, or the same.
I'm going lower
So
on
7.
7. Feel good about a lower.
7 heaven.
I don't want to influence anyone, but I did massively.
And it is the same.
Sorry, guys.
Okie dokie.
Don't listen to me.
How are you getting on, Joe?
No, not very well, I don't think.
Higher, lower, all the same.
Yeah.
7 could be another 7. Who knows?
Who knows? I'm going on another 7.
4 in the deck.
Yeah. Repeat. Come on, the same.
And it was higher. 29% of you
How
got
many
that
more? I
one.
think we're down
Congrats,
to-
guys.
We're getting very close to the end here, I think. This last one. How did
Certainly
you
are.
do? Oh, you've got to get this quick. That is brilliant. I want to see the percentage saying a silly game. Oh no, silly game 62%.
62%. Great. 57.
Thanks, guys.
Yeah,
Good to
that's how the
know.
cards
Good
fall.
one. Lovely.
Congratulations to Kushwant Sharma taking it down. 4 out of 6 correct. 30 seconds. Bang on. And commiserations to Sebas, Ryan, Hajar, and Sergey, who also made the top 5. So well done, guys. We'll get you over a pack of Gopher limited edition playing cards, Kushwan.
Yeah, well done, man.
And without further ado,
I'm going to pass you over to Egon for the talk here. So bear with us one moment.
okie
Just,
dokie.
more.
We'll make you the host, Egon.
Okay.
Give us 1
2
second.
seconds. Who's the host on it?
How do you get the host here? Sorry, we're just having a technical issue, pretty standard.
Well, maybe you are the host already.
No, I'm not. Hmm.
Right, pretty standard stuff. We got more down there. Right, okay. I think we're going to have it. Yeah, all good, guys. There you
Right,
go.
we'll love you and leave you guys.
See you
So
later.
Okay.
enjoy.
So I hope everybody's seeing the slides. Okay. So this talk is going to be about production-ready concurrency. And what I mean by that is like backend services and server kind of stuff. I won't be able to explain everything or every rule that I'm kind of giving you because every single one of them requires actually working through the problems yourself. I cannot just give you the knowledge of concurrency immediately. However, there's a disclaimer that this, of course, comes at the cost of performance, and maybe there's more lines of code. And of course, there are plenty of exceptions where these rules don't necessarily apply. A good example would be scientific code that requires different set of properties to use. However, I think this is these are good rules for most of the applications. And if you don't have time to like completely follow through the ideas and examples, so you'll get the slides later and you can go through them and kind of try different things. So I've divided it into like these three sections. So one is like giving you these general ideas on what to do and like things that will lead you in the right direction. Then the second part is like what you should use to build your concurrency in your system. And finally, the third part is about kind of building your own custom different utilities that help you write correct concurrency. Wait, I'll move that chat here in case there's a question that I can answer immediately. However, let's go into the rules of thumb. The first thing is no global variables. It's going to, like, it has been covered in depth in many blog posts and stuff. Essentially, they complicate your concurrency and you have a high likelihood of different things cross-talking and kind of introducing different issues. So no global variables, logs, caches, pools, anything that can be considered shared variable between different instances. Then a common problem I've seen is that people use concurrency because they can, not because they are required to. So this isn't too uncommon, but yeah, don't use concurrency if you don't have to. It's much easier to work without concurrency. So yeah. Then there's this idea of preferring synchronous APIs. I see a lot of people designing APIs that are kind of start this asynchronous process and then stop it and wait for it and so on. Usually the synchronous API, which just says, oh, do this, is much easier to manage from the caller's perspective because it's usually trivial to make something asynchronous because there's only one way to make a synchronous API, you make a call to something. However, the asynchronous APIs can be much different or vary quite a lot. Then we have, you need to know when things stop. So if you have started the coroutine, there should be something that waits for that coroutine to finish. If you don't have that property, it can introduce different problems. I'll show an example later about it. So always wait for your coroutines to stop. Then one of those things that you need to handle is cancellations. There's plenty of cases where you need to kind of shut down your system, and a good way to do that is by using context types. They have a built-in cancellation mechanism, so instead of sleeping, you can kind of wait on the sleep itself, and then kind of and also select on the context finishing. This kind of means that if you get the cancellation, it doesn't need to wait for the full second, but it happens immediately. And often, if you have time.sleep in your concurrent code, it indicates some sort of problem. The only exception is usually retries to an external service. And that's, I guess, about it. The second part is if you have something, a long-running process, then you do want to check for the context cancellation. So in this case, for example, if you're iterating over files, you can check for whether the context has error and then kind of abort if it should be. This is the same thing that you want to react to these cancellations and kind of handle server shutting down or anything canceling their request. Then one of those things that people start to immediately port over from different languages is using worker pools. Brian C. Mills has a really nice talk explaining why it's bad and different reasons, but as a general rule, don't use worker pools, implement something more different that starts coroutines only when they are needed. Because if you have 10,000 coroutines in the background in the worker pool, then you're going to kind of mess up all your stack traces and you're never sure what's actually doing anything useful. And as I already mentioned, sleep is usually bad, indicates some problem. You don't want to be polling some local variable that you have because it wastes resources. Instead, you want to react in different ways to the changes. There are different ways how to do that, but that would be a different talk entirely. So I'll skip this, how to do this here. And the additional thing is, if you have something unlocking or something that definitely needs to happen, then defer it instead of kind of writing it manually. It's easy to forget this unlock or change the code in a way that the unlock isn't called. This could be also any channel sense or channel closing or anything, or waiting for something to happen. So yeah, defer these things. And one really common thing people do is expose their locks on their concurrent data structures. Just don't. It kind of gets you easily into the problem of deadlocks between different types. And it's not always obvious where they occur. If you kind of avoid it in the first place, then it's much more difficult to introduce these issues. And finally, name your coroutines. This is a really helpful tip. If you get your stack traces, then you can easily kind of see, oh, this is some database patching background job, and this is the request handling service. So yeah, name your coroutines. So this is essentially, if you take anything away from this talk, then like these ideas will guide you in the right direction. And the issue is that it might be difficult to then figure out like what's the right thing to do if you like, or how to do these things safely. So let's choose our concurrency primitives. As I mentioned, there's it's easy to use things in a problematic way. So as a recommendation, this is how you should evaluate, like, what should I use to implement concurrency in my system? So if I need to protect some concurrent state, or if I need to start some coroutines or anything like that. So generally, if you cannot get by without concurrency, then don't use concurrency. There are really nice packages. There's x/sync, so the extended Go library, which has different synchronization primitives that are pretty good. We'll look one of them a bit later. Then you should consider implementing your own custom type or using some external library, something else, because it's much easier to implement a concurrent primitive outside of your kind of domain logic compared to implementing this concurrency synchronization inside the domain logic itself. I've seen plenty of cases where people get it wrong in a small way, and in concurrent system, that's all it takes, a small mistake. And then you have sync mutex, which kind of is mostly for special cases. I'll speak about those later as well. And everything else in the bottom part is just to implement your custom solution, or kind of implementing wrappers, or kind of to get the job done of implementing your primitive. So this is the first problem. I guess we can pose the question.
Cool. Okay.
And-
Now.
Yeah. So there's something wrong with this code, and you,
One will just need to join it again.
yeah.
Everyone's going to pop in their name.
Yeah.
And then I'll show it.
Yeah. So in the first one, you'll get some extra time to figure out what's the problem, but later, I guess it will go a lot quicker. So the question is, what's wrong with this code? There's the...
I'll start it now.
Okay. So I think we can show the correct answer now. So which is that this database might be closed here. Why? Because because this server starts this coroutine that is kind of going on in the background, and when it's shutting down, then this database might be already closed. So due to this close happening some asynchronously with all this serve HTTP thing. So yeah. Wait, I lost the chat. Is it clear why it's using this as a closed resource? Yeah. So yeah. So it's one of, and yeah, of course, there's a potential other problem is that this request might be closed as well. Okay, we can then go to the next problem. What's the problem here? So yeah, looks like most of you got it correct, which is that it's early finish. In this case, it might that the first item increments this sync wait group in the process function and then like finishes the process, and then this wait here finishes before any other asynchronous like any other process can start. So yeah, so they are logically racing, which means that the race detector won't find it, but it will be an issue. So problem number 3. Okay. Yeah, so in this case, yeah, this number of added items is different from how many times this done is called. So it's with wait group, it's easy to introduce these bugs when you're kind of writing it. You need to be really aware when you're adding and when you're deferring this done. And this could be an accidental mistake that was introduced later in when somebody like decided, oh, I don't want to iterate over all files, but just .go files, right? And maybe they didn't test it properly and only tested it on a folder that has Go files. So it's an easy bug to introduce. So what can you do about it? So what you can introduce is these tracking primitives that handle or remember which coroutines you've started. Here I just show some random one. You can implement it in many different ways. But here you can ensure that all of these asynchronous things you are doing are finished before this server finishes processing things. Of course, this also means handling these cases of when the server is shutting down. Should you start this asynchronous process in the first place or not, right? Because in some cases you do definitely want to finish it before the server shuts down. In other cases, you may want to return an error to the one that made the request. So there are many options here, of course. And what can you use to track these things? A really good one is sync error group. It has two behavior modes. One is on the left is for when you start these coroutines, you can wait for all of them to return on their own in whichever mechanism. The other on the right is when one of them fails, then the context that is passed into those functions is cancelled. So you get this, when one fails, then the other will return as well. So I do recommend using this if you don't want to implement your own, or kind of, it usually handles these cases pretty well. So problem number 4. And we'll assume that this cache is quite frequently used and large. So yeah, in this case, the issue is that we're not cancellation aware. So we might kind of hold on to this lock too long, or kind of let's say you have 1,000 requests made concurrently, then they all will block each other. And let's say half of them cancel their request, then nothing will happen to them. They will still be queued here, and they will still need to handle this all this logic. What you can do here is replace the sync mutex with a channel. Brian C. Mills also describes this in his talk, so I highly do recommend looking at it. But here we are using this single item channel to store the state instead of protecting it with a mutex. And of course, if this evict old items is also slow, you want to pass this context into there, and also kind of, yeah, be aware of maybe that is slow as well. So a general statement about sync mutex: treat it as something to protect small values for a really short time. And you don't want any for loops in those in the handling. It's kind of a good approximation, but you should also measure like whether it makes sense in your context. And there's also read-write mutex. It has similar problems like mutex, but it's also usually slower. So have a benchmark to demonstrate that using this read-write mutex is faster than just the regular mutex. So regular mutex usually beats read-write mutex. General problem number 5. Okay. What's the issue here? So in the chat, there was a comment about that it goes too quickly to fully read the code. That's usually the situation with people doing code reviews. That's how long they kind of look at the code. So it's quite representative how long you actually can, like how long you have to detect the issue with the code base. So, yeah, so that's why you also need to pay attention when handling concurrency. So the issue is that this work queue is not being closed. So yeah, it's a simple problem that even a really experienced developer can make. Like forget this single line of code and it deadlocks. In this case, the usage of wait groups is of course correct. Finally. So this is why this order of preference is written that way. You want to avoid these things in your domain code. So one is channels, or making them at least. Starting coroutines with gofunc. Usually you want to use some sort of primitive, and as a similar case, you need, as a result, you avoid sync wait group. So yeah. However, using select is usually fine, which is interesting. But yeah. So if you cannot use them, what should you do then? If you have some problem that needs some synchronization. There was a question why we range but did not write to channel before. Oh, because it's asynchronously kind of starting this work queue, and we don't need to write it before. We can do it in either order because they are running concurrently. So it wouldn't make a difference. Well, it actually would, because then it would deadlock sooner, because this iterate items needs to complete before starting this worker count. So let's go to showing how to implement a few custom primitives. So this is the, I guess, the practical side of things, how you would implement these, or handle these cases in domain code. As I mentioned, there are many variations on these things, and you need to kind of figure out what makes sense for your code base. So you probably want to alter these things to suit them better. Okay, let's take a simple problem. You have a slice of things, and you want to concurrently process this information. Usually, often people kind of do some worker pool thing, or they will make a channel to kind of pass this information along. However, what you can do, I'm currently not limiting the number of things that can happen concurrently, is that we kind of course, use these different primitives to say that, oh, I want to process this many items, and each of those batches should be appropriately sized, and I'll start a coroutine for each of them. And the usage of that would look something like this. So, yeah, we start these functions concurrently. We'll add up locally in a coroutine, and then, of course, finally we'll modify this total value with by protecting it with mutex, because like addition is trivial. In this case, it would be possible to use atomics. However, atomics are much easier to get wrong as well. So, and if you're doing something more complicated, then you cannot often use atomics. So yeah, a really simple, well, I say simple, it's easier then kind of folding all this logic into the right side of the code. It will make it much more clear what's happening in the domain code. And of course, in some cases, you may also want to pass in the context. In this case, it might be more of a scientific approach where you almost always want to finish the job. Or you may want to add some other logic into the parallel implementation. Okay. So we can then take this sleeping problem. Sometimes you do need to sleep for retries. Then what you can do is implement, that shouldn't be a ticker, it should be a timer, but nevertheless, you can start this, make a separate sleep function that handles this context cancellation. And usage looks like this. So you can, of course, detect the error and all that stuff. So these utility functions to help with you with the concurrency and channels and all that management don't have to be complicated. Although they could be if you wanted them to be. So I have 2 API examples how you could implement retries. So one of them is, let's say, looks like this, that it retries 10 times and initial retry is like 1/10 of a second, and then incrementally increases it to 1 second, and then kind of has this for loop for retrying. The alternative is to use callbacks. So it depends on your problem, as I mentioned, which of these fits better, which of these usages. So there definitely are options here. And we can then also write helpers to start concurrent functions. So this might look quite verbose. However, like what it helps you to do is you can immediately see, these 3 functions are started concurrently, and it doesn't return until all of them return. Well, depending on your use case, you can also add this other property of when one of them fails, then the all other ones are cancelled as well. So yeah, whichever makes more sense. Yeah. And now we can, of course, go to. I don't have a repository, but I'll give the slides. I think it's really beneficial to work these through and rewrite them yourself and write tests for them. So, yeah. So now we get to some more complicated things. Let's say you want to wait for some other event to happen concurrently. So in this case, we can implement something that's usually called a fence. There are other ways to name these things, but yeah, let's call it a fence. So one of the things I'm doing here is making sure that it doesn't require a constructor. This can be really nice when using these concurrency things because you don't have to then initialize them and just can use them. Similarly, how you can directly use a mutex or wait group or error group. So it always kind of tries to initialize itself with using this sync once and ensures that there's always this wait channel there. Then, of course, this release means that it will release anything that's waiting for it. And optionally, of course, it will expose this channel in case somebody else wants to use it in a select. And they cannot use wait directly. So how using this primitive would look like? Something like this. We have this loaded fence, which means that once this is released, then this data is as it should be. So we have this, we're using now this concurrently primitive or utility we implemented before. So to fetch some data from some URL, and then all of the other coroutines are waiting for this loaded fence to be released. And that way I can kind of like properly ensure that it's available there. Of course, you can implement something that looks like more like a promise, and as I mentioned, so many different variations for that. There's a question, for example, here: if the get data fails, should you have a way to, let's say, cancel this fence, or some way of communicating this error to the other concurrent processes or coroutines? Then we can look at some things that you usually use a mutex for. You can write a simple helper function. This could be private or not, that handles this, like using a channel to protect your state. And using it would look something like this. So yeah, you can make your lives easier with these utilities or primitives. And finally, something I guess more in-depth is a limiter. Or, well, one of the last things is where you want to limit the number of coroutines you start. So in the and so like instead of worker pools, you can use a limiter usually. So that's why this is an interesting example. One of the things we immediately check is whether the context has been cancelled, because if there's a limit that we need to wait for, so in the select statement, this context done and limiter limit might be true at the same time. So if you have cancelled this context, you don't want to start this coroutine in the first place. So because select will randomly pick one of the cases if both are true. And then we, of course, add to the counter of wait group, then defer in the coroutine, defer like clearing the limit and the limiter working done, and finally start this function. And of course, we return always this true or false, whether it actually succeeded. And we'll have this some sort of way to wait for the completion of all of these workers. And to make it even more complex, we can take something even more, is this doing some background thing. So in our server, let's say, we may want to start some sort of like this tracking tool that tracks these pending database requests. And of course, we defer this wait such that later something else can later. So in the first problem, we close the database too early, but by waiting this for these coroutines to finish, we can ensure that these coroutines have been shut down properly before. Yeah. And how would you implement this is quite similarly to this limiter. We have this server context that tracks like when the server is shutting down, and we use, in this case, we'll use error group to track these different coroutines. And similarly, before we in the go function, which we check for this request cancellation or server cancellation, and kind of only then we'll start this coroutine. And similarly, we need to kind of, if we, let's say we had this limiter, we need to like ensure that we do check this context cancellation before calling select. But yeah, this went a lot faster than I expected. But this also means that you have much more time to ask questions if something was unclear. However, I do recommend watching this talk by Brian Mills that talks about similar things. Then there's Little Book of Semaphores by Alan Downey that has a lot of different concurrency problems and issues that you can introduce. And working through these exercises will make your concurrency understanding much more solid. And finally, the understanding real-world concurrency bugs. It's a really nice paper on like different things that people get wrong. And if you have later any more questions that you don't get answer here, there's best practices in Gopher's like that. Probably it's a really nice place to ask concurrency questions. So I'll find the right button to give the presentation or the hosting capability back and make host.
Thanks, Egon. That was great. Thank you for that session. Really enjoyed that. Very insightful, and I'm sure the questions that have been submitted are going to be really interesting. We've had lots of great questions. So just want to quickly introduce myself. I am working with Gophers in the Netherlands. So we have clients and we have some awesome Gophers there. So it's great to see some of you guys attend today as well. And yeah, just wanting to kind of highlight a couple of the key questions and then get your input for some Egon, we have a little bit of time here. So yeah, the most ranked question with the most number of upvotes came from Supritha. Congratulations to you. We will be sending you out. We'll be in touch with some prizes. We can email you and offer the most relevant prize. And the question, which I'll hand over to you, I'll just spotlight you as well so you can answer. But yeah, the question that we have is why Go routines instead of threads?
So I think that might be a little ambiguous question, but it's mostly about performance and using less resources. So it means that when you start a coroutine compared to starting a thread, one uses up a lot more memory and is much slower. So coroutines you can pretty much create similarly to like creating any other data type, but threads usually use more resources. So yeah, it's mostly performance related. It of course comes with some downsides with regards to interacting with other systems, but yeah, that's about it.
So it's more efficient to use Go routines.
Well, it makes it easier to use it's more efficient to use coroutines, but at the same time, it doesn't necessarily mean that you cannot write performant code with threads. So yeah, it's a more useful primitive than thread, I would say.
Perfect. Awesome. Thank you for that. Well done to Supritha. And with the second most upvoted question, we had a couple of questions submitted by Sega. So the one with the most number of upvotes here was how to identify Go routine leaks in our application, and does it affect application performance?
Yes, it does affect application performance. Usually each coroutine does take up some amount of memory. if they also are kind of spinning or doing something constantly in the background, then even more so. I haven't found a really nice way to identify coroutine leaks other than at the end of tests, check that there's only like the things you expect to run. So there's, I had this, I'll post in them. Yeah, I feel like there was some tool to catch, I wrote something to catch the things that have deadlocked, however, not things that have leaked entirely. So there's, so yeah, there's not a nice way currently, but like I did write this package quite a while ago. I'm not sure whether it still works, but you can get some ideas how to write some tool to detect things that have spent too much time in a lock, right?
Perfect. Yeah, I will send that. I'll put that in the group for everyone. Awesome. And then I guess coming on to the final question, again submitted by Sega, was how to close the channel in case there are multiple concurrent senders. Since the sender before sending may not know if the channel is already closed by another sender.
So in that case, you can introduce, how to say, some supervisor that manages these concurrent senders. So if that, let's say, this one of those concurrent senders wants to close the channel, it can kind of contact this supervisor, maybe coroutine, that then cancels all the other concurrent senders, maybe through some context cancellation. And once they have all stopped, then you can close the channel, right?
Mm-hmm. Awesome. Perfect. Thank you for your responses there. Unfortunately, that's all we have time for, but we do have a couple more questions. I'll do our best to get these sent over to Egon, if we can maybe get these answered offline and then distribute to all the attendees today. But yeah, some really great questions. Hopefully we were able to get those answered, and very kind of you to share your some of your old tools. And I think it was a really interactive way to kind of look at the technical code and how you presented that. I think it was great. So awesome. So I'm just going to hand over now to the two Joes, where we'll do a kind of final thank you and farewell.
Hey there, guys. I think I'm coming through all right. Right. Yeah, I think as long as you guys can all see us, it was big thanks to Egon there. Really appreciate the chat. A lot of interactive stuff coming through on Slido, which is great. Really pleased to see, so many questions. A lot of you guys voting on it as well. Yeah, obviously, congratulations to the winners of those questions, of the quiz, and of course the card game. Really impressed with it all.
Yeah, we have three winners. Kush took down the card game, kicking things off. We had Tao, who was the tech problems winner. And then Sufritha was the most upvoted question. So thanks for taking part in that, guys. And really appreciate your time, Egon, and sharing your knowledge. I know it was a little bit deeper technical today, and certainly with the post-event video, it'd be a good one to digest and really think through those problems, because I know Egon's done some really impressive stuff in the industry, and I'm sure there'll be a lot of value there, taking time to really go through some of the stuff and the topics that he talked about today as a nice kind of add-on from Preslav's talk a couple of weeks ago. So look, fantastic to have you all there. We do have another one coming up in a couple of weeks' time, tuning in from San Francisco, Mary Chris, who's going to be talking on some new SDK platforms, how it interacts with Go, pretty cutting edge stuff that she's got a talk prepared on. So we'll share more details on that too. And yeah, hope to see you guys there.
Yeah, absolutely. Seeing some stuff coming in on the chat and a lot of questions coming in through LinkedIn about these videos. They are ready to go. So in due course, we're going to be sending out links to both the previous videos, Egon's one when it's ready. So they are going to be accessible to everyone and the community, completely free. Don't worry, guys, they're ready and they will be sent out. So I just want to let you all know. And yeah, look, thanks for making it a record-breaking event again. Record numbers. Really pleased with the way this is going and sharing so much info with the community. You guys are great. Don't forget to give us a follow on LinkedIn to get all of the updates on these upcoming events. And of course, visit the website to find out more about what we've got coming up. Really, really pleased. And look, I can't wait to have you at the next event in a couple of weeks' time.
All right, guys, take care.
See you later,
Cheers,
Egon.
Egon.
Thanks, Egon.
Thanks, everyone.
Thanks.
Bye, guys.
Bye.
Bye-bye.
See you guys.